Hey Math 10C, so now we're getting into lesson 5.2, linear equations still, but now we're going to be doing what's called the substitution method to solve for linear equations. So in the last lesson, if you remember, we were graphing them, right? So you'd have some graph, and then maybe that was one of our lines, and that was another line. And then it was where they crossed is what our solution was. So let's say this was at the point 3, 5. Well, then our x value would be 3, and our y value would be 5, right? So that's how we were doing the last lesson there. So now what we're going to be doing is solving these things using algebra, right? We don't actually need to graph these things every time to solve for them. So, all right, let's get into some examples. So this example kind of lays it out really nicely to show you how to do it. I'm going to do this one with you too, because I think it's more of a straightforward one. I'm going to just do the same question. I think it's just on the side here to show you the steps. So if we had 3x plus 2y is equal to negative 11, and then negative 2x plus y is equal to 12. Okay, so now why it's called the substitution method is I am going to substitute one of my equations into the other equation, right? You might not know what I mean yet, but that's fine. I'll kind of show you as we go here. So the process is I want to rearrange one of the equations. It doesn't matter which one. I want to arrange one of them so that it says either y, so it says y is equal to something or x is equal to something. Okay? Okay, and just follow my train of thought here. I promise it will make sense here in a second. So I'm going to rearrange this bottom one so that it says y is equal to, some equation or some expression there. And the reason why I chose this one is because it's already set up nicely, right? This one is just y on its own. This would be a little bit more work here because I'd have to, in the end, divide everything by 2. So I think I'm gonna do this one because it'll be a little bit easier. So let's start off with this. So I'm gonna rearrange that guy. And here, you probably saw it change color. I made it blue just so we can actually see the differences here when we do it. So I'm going to rearrange this, and I'm going to add 2x to both sides right off the bat. So plus 2x and plus 2x. So then here we've got y is equal to, and I'm going to write it as 2x plus 12. But it would have been fine to write it as 12 plus 2x. It wouldn't have mattered. All right, so now I have my two equations, right? So I've got this one, and I've got this one. All right, so here is why it's called the substitution method. I'm going to substitute one of these, this one, in to this one. And you might ask, why are we doing this? Let's actually just think about this for a second. If I was going to solve, let's say this, 3x plus 2y is equal to negative 11. If I was to solve this using algebra, well, typically I would get the x's on their own, right, or the variable on its own, and all the numbers to the other side. Here's my problem. Which one do I get on its own, right? I've got an x and a y. How do I isolate for x or y if I've got two of them, right? So what we're going to do is we're going to do a little trick here where we're going to make it so this equation is all in terms of x or y. It doesn't matter which one. So what we're going to do is we're going to sub that into that. And here's what it is. So we're going to rewrite this now as 3x plus 2, but instead of a y, I'm going to write what I know y is equal to. What is y equal to? It's equal to 2x plus 12. Okay, so I'm going to sub 2x plus 12. Oh, sorry, I should have made that red. One sec. Just so you can see it. 3x plus 2, and now I'm going to sub in 2x plus 12. And that's equal to negative 11. Do you see how this right here, that was y? That's why it's called substitution. I'm substituting in that expression instead of a y. And then if you look closely at this just solved a problem for me, right? Before, I couldn't just get x on its own because I had x and y to deal with. Now I just have x's. Now this is just straightforward. This is just algebra. So then we just have to get x on its own and solve for it, right? So if I want to if I've got these brackets here now, right, the next step is to get rid of those. So we're going to distribute the 2, and we're going to get rid of the brackets on this one. So we'll write this as 3x plus, and then 2 times 2x would be 4x, and then 2 times 12 is 24, is equal to negative 11. Okay, so now I'll combine these like terms. 3x plus 4x is 7x plus 24 is equal to negative 11. Now I need to get x on its own, right? So which one do we do first? The 7 or the 24? Well, the 24, right? That's the farthest one away, right? It's least attached, or it's less attached to the x. So we'll subtract 24 from both sides. So minus 24 minus 24. So we get 7x is equal to 11. Negative 11 minus 24 is going to be negative 35. And then we'll divide both sides by 7. So then divide by 7 and divide by 7. So x is equal to negative 35 divided by 7 is negative 5. So there we go. We solved for x. We are half done because we need to solve for y. Right? Because that's going to be our solution. This is like when we graphed our equations last time, right? Remember how we found an x and a y? There's 2 numbers that we need. We need our y value now. But this won't be so bad. And I'll tell you why. Okay, so we already have an expression set up to solve for y, right? That's actually why I like the substitution method. Because now to solve for y, I can just throw in negative 5 for x. I can say, okay, well then y is equal to 2 times negative 5 plus 12. Oh, that's kind of weird the way I did that. Plus 12. Okay, so y is equal to negative 2 times negative 5 is negative 10 plus 12. So y is equal to 2. And there you go. There's our solution to that system of equations. Let's do a bunch. So moving on. Let's do this question. So it's going to get a little tougher, and the only reason why it's going to get a little tougher is because we're going to be kind of throwing in some fractions into the mix, but all the steps will be the same as above. Okay, so same as last time, we want to get something something on its own, right? We either want to get x on its own, or we want to get y on its own, and we can pick either equation. I'll pick this one, and I think I'll solve for, you know what? I'll solve for y on this one, and the only reason for that is because I can tell I'm going to divide everything by 3 at some point, and 9 divided by 3 is 3, which is not a fraction, so it might make things a little easier. So let's do that first. So I'm going to just rewrite this one. So we'll write it as, well, let's bring over the negative 2 first. So I'll divide both sides by, or sorry, I'll subtract 2x from both sides. So minus 2x minus 2x. So I've got negative 3y is equal to negative 2x and then plus 9. And then I'm going to divide everything by negative 3. So divide by negative 3, and it's everything by negative 3. So divide by negative 3, divide by negative 3. So we get y is equal to negative 2 divided by negative 3 is just positive 2 over 3x. And then 9 divided by negative 3 is negative 3. All right, so we have it set up. So y is equal to that. Okay. Now, I'm going to put that into my other expression. So that will be 5x minus 3y is equal to 18. So do you see what's happening here? Y and y. Well, I'm going to be throwing that one into there. Okay? So let's write it out again. So we've got 5x minus 3, and then I don't want a y. I want this, because that's what y is equal to in terms of x, right? So let's put that in. So that would be, so instead of a y, we've got 2 over 3x minus 3. And then that's equal to 18. Okay. Now we're good, right? we've got everything in terms of x, right? There's no more y's there, so now we can just solve for x. So we've got, oh, sorry, that should have been red. Really not sticking to my theme. Okay, so there you go. And then let's write it out again here. So now we've got 5x minus, okay, let's look closely at this. So this is going to be negative 3 times 2 over 3. You're going to start getting good at these, but for now, just write it out if you need to. We've got negative 3 times 2 over 3. Okay, well, do you remember how like negative 3 is like negative 3 over 1? And then we just like multiply straight across. So you might say, okay, well, I know this. This is negative 6 over 3. And then negative 6 divided by 3 is negative 2. Okay, that's right. We could have done that a little easier, though. At this point, when this was, did I say 2 over 3? I've got a 3 on the top, and I've got a 3 on the bottom. They cancel, and I end up with negative 2. Right? 2 over 1 if you like, but it's just negative 2. So that's why this becomes really nice situations like this, because I can just see from looking at that, 3's cancel. That's negative 2. So, yeah, that makes life a little easier. So now this is just negative 2x. And then negative 3 times negative 3 is going to be positive 9. And then that's equal to 18. Okay, collect like terms. So we've got 5x minus 2x is 3x plus 9 is equal to 18. And then minus 9 minus 9. So we get 3x is equal to 9. So divide by 3. Divide by 3, so we get x is equal to 3. There, half done. Not really, we're pretty much done. So now let's throw in x for, or throw in 3 for x, right? So we have an expression for this already. So we'll write this out one more time now. So this will be y is equal to 2 over 3x minus 3. So we're going to throw that 3 in for that. So now y is equal to 2 over 3 times 3 minus 3. Now, the same nice little thing happens here. 2 over 3 times 3, again, those nicely cancel. That's just 2. So then 2 minus 3, so we get y is equal to negative 1. So our solutions here are x is equal to 3 and y is equal to negative 1. If it asks you for like to write this as a point, right, because this would actually be a point on your Cartesian plane, then that would be the point 3 comma negative 1. Right, there's your x value and there's your y value. All right, more problems. Actually, you know what? I'll let you guys look through this one. Let's jump to the next one here. All right, solve this linear system. So, all right, we got m's and n's this time. Doesn't really matter. I think the easiest one here is probably to solve for m first, right? Get m on its own. So let's do that. So we'll just subtract 5n from both sides. So minus 5n minus 5n. So we get m is equal to 70 minus 5n. Or negative 5n plus 70. You'll get the same answer either way, right? So, all right, so there's one of our equations, and there's the other. So let's write that one out again. So this was 2m is equal to 10 minus 2.2n. All right, so m is equal to this, right? So this is going to be going in right there, right? That's what m is. It's equal to 70 minus 5n. So we'll throw that in. So this will be 2, and then instead of an m, I got 70 minus 5n, and that's equal to 10 minus 2.2n. All right. So now this one isn't really any harder. We just have decimals, right? So we just have some, we just might have to throw or bring the calculator out this time. So we will multiply the 2 in. So that's going to be 140 minus 10n is equal to 10 minus 2.2n. All right, so the idea is, like in the last questions, we just collected like terms at this point, right? But the problem now is they're on the wrong side, right? So I think what I'm going to do, let's bring the 10 in. So I'm going to add 10 in to both sides. And I'll just do one at a time so you can see it. So plus 10 in. So we got 140 is equal to 10. And then we've got negative 2.2 n. So negative 2.2 plus 10. Right? So that's going to be 7.8. So positive 7.8 n. And then we'll subtract 10 from both sides, so minus 10. So we get 130 is equal to 7.8 n. And then we're just going to divide both sides by 7.8. So 130 divided by 7.8 is 16.6 repeated, or 16.7 is equal to n. All right, almost done. Okay, so we'll start again with this equation because we want m now. So m is equal to 70 minus 5n. So then m is equal to 70 minus 5 times, and then n was 16.7. Okay, so m is equal to negative 13.5. And there you go. So one thing here, just notice that the way I answered this, I had to round this 16.7, and that ended up probably giving me this one a little bit off too, because I had to put 16.7 in there. The other thing that we could have done to be a bit more accurate is we could have rewrote this 2.2 at the beginning here as 22 over 10, or 11 over 5, right? We could have just rewritten the expression as 2m is equal to 10 minus 11 over 5n, right? And then we have a fraction, and it's kind of annoying, but we would have ended up getting the proper fractions in the end there. But I think for now, that was just as we're getting our bearings here, this is probably good just to leave it as a decimal. But we will be doing questions like that, so. All right, so let's do the next one here. So Alexa invested a total of $1,800, part at an annual interest rate of 3.5%, and the rest at an annual interest rate of 4.5%. After 1 year, the total interest was $73. How much money did Alexa invest at each rate? All right, so we got to figure out what our actual variables are here, right? So if she invested a total of $1,800, and it's saying part was at this and part was at that, and it's saying how much money did Alexa invest at each rate? Okay, so what it's asking for is, like, you know, what was part 1 and what was part 2, right? What was the first chunk of money and what was the second chunk of money? So we can make our variables whatever we want. I'll stick with the x and y, right? So let's say that we know that she invested x dollars plus y dollars to give a total of $1,800, right? That's one part and that's the other part. Okay, so there's my first equation. My second equation is a little bit tougher, right? So it's saying that the first part was at 3.5%, the second part was at 4.5%, and she ended up making $73. All right, so we got to figure out, you know, percentages of the parts, right? So she's saying the first part, so x, was 3.5%. So remember, when you write percentages, when you want to figure out what a percentage is, you write it as a decimal. So this would be 0.035, right? That is 3.5%, just divided by 100, right? Written as a decimal, the decimal place moved over 2 times. Okay, so it's that times the amount for x, right? So times x, right? That's the percentage that she made for the first chunk. And then she also invested the second chunk, right? So 0.045 times y. And that added up, right? This percentage of that one and this percentage of that one ended up adding up to $73 in the end. Okay, so there's our 2 equations, right? Now you're probably guessing which one we should rearrange for. It'd be kind of annoying to rearrange for y in this case, I think we should probably rearrange for x or y in the first one. We haven't done rearranging for x yet, so let's rearrange that one for x instead. So really all we're going to do here is just bring the y over to the other side, right? So that'd be the same thing as saying x is equal to 1800 minus y, or negative y plus 1800. Okay, so that's going to be the more useful one, right? Okay, so that's an expression for x, and we have an x sitting right there. Why don't we throw this one into this one, right? But instead of writing x, we're going to write 1800 minus y, because that's what x is. Okay, so we'll put that one in. So this would be now 0.035x, no, not x. I just said we weren't doing that. Times, so in brackets, and then we're going to put in that expression. So 1800 minus y, and then plus 0.045y is equal to 73. And then I know there's decimals here, but it's all the same steps. We just need to bring out the calculator. So in this case, I've got those brackets. I need to distribute that out so I can figure that one out. So 0.035 times 1800, so 0.035 times 1800 is equal to 63. So that's 63, and then this will be minus 0.035y, and then plus 0.045y is equal to 73. Now we are going to collect like terms like normal. Okay, so I'm going to collect those guys. So we've got 63, and then negative 0.035y plus 0.045y. That's like 0.045 minus 0.035. So you just end up with positive 0.01y is equal to 73. And then I'm going to subtract 63 from both sides, so minus 63 minus 63. So we get 0.01y is equal to 10. And then divide by 0.01. Divide by 0.01. So y is equal to 1,000. All right, and we really did do all the hard work here, right? Because if we've got this expression, right? X plus y is equal to 1800, and I just found out that y is 1,000, then x must be 1800, right? But either way, we could plug it into this one too. So x is equal to 1800 minus 1,000, so then x would be equal to 800. There, solved. Question 4. So an 82-meter cable is cut into 2 pieces. One piece is 18 meters longer than the other. What is the length of each piece? Okay, just to change it up, I'll use A's and B's this time. Doesn't really matter, but same idea kind of as above. If it's cut into 2 pieces, then I think it's safe to say that we could say, okay, piece A plus piece B is equal to 82. Yeah, the two of them together. So there's our first equation. And then our second equation, we have to figure out from here. It says one piece is 18 meters longer than the other. So I'll say A is equal to B plus 18. Right? So A is 18 meters longer than B. Okay? Because it's B and then another 18. All right. So, all right, this one actually should be pretty straightforward. We don't even really have to arrange anything because it's already set up. I can just really put this guy, so this is what it was A is equal to. Let's just throw that into that one. So, here, I'll just write this again so we can figure out what we're doing. So A plus B is equal to 82. So instead of an A, I'm going to replace that with B plus 18. Because that's what A is. A is equal to B plus 18. plus B is equal to 82. So I put that in brackets. We didn't really need to, right? Because we had nothing to multiply, had nothing to distribute there. So those brackets can just disappear. So I can collect my like terms there. We've now got 2B plus 18 is equal to 82. So we've got now also, we'll subtract 18. So minus 18 minus 18. So we got 2B is equal to 64. And then just lastly, just divide by 2. Divide by 2. So we get B is equal to 32. Okay. And then we can kind of throw that into either one. So we'll throw it into the red one there though. A is equal to B plus 18. So A is equal to 32 plus 18. So A is equal to 50. All right, and that's it.